Hi, so right now we are working on graphing the function f of x equals -3 cosecant of 2x plus 1. Now as we know, the cosecant is equal to 1 over sine because it is the inverse function of sine. So the first step to graphing the cosecant equation, or the function, is first graphing sine and then graphing the corresponding cosecant equation. The reason we start by graphing sine is because sine is an inverse relationship to cosecant, meaning that the operation of sine has been reversed. Typically, inverse relations are used to find a certain point on the graph that is unknown, and by simply reversing the equation, we are able to find that point. You can see the inverse relationship here with cosecant and sine, where cosecant equals 1 over sine, which is the inverse of sine. Let's look at this sine graph. The first thing we do in order to graph sine is find where the function intercepts 0. A sine function typically begins at the 0 point, instead of the 1 point, like cosine would. And that is because on the unit circle, we see that at 0, cosine equals 1 and sine equals 0, which is the difference in graphs. So in this case, the horizontal asymptote, which is represented by this +1 here, will be at 1. Typically, this in other functions represents the y value, and you see that like this starts on the y-axis at 1. So that is what this does. These periods right here represent where a point equals 0 on the graph. So we see that here, this point, pi over 2, has a 0 in the y value. Here's another 0, another 0, and another 0. Now, when graphing cosecant, we're graphing the cosecant to look like this, because cosecant cannot equal the 0 of sine, because it is an inverse relation. These periods right here are created by this number right here, 2x. Whatever is next to x is what determines the width of each of the humps, or of each of the sine graphs, which are these things, when it comes back to 0. For a regular sine function, where sine of x equals f of x, the 0 would intercept at pi, because we see here at pi, sine is 0. So by adding the 2 in front of the x, we are shortening the periods in which, where the sine graph will intercept 0 by 2 lengths, as we see here. So now the sine graph is intercepting at pi over 2 because we have this 2 in front of the x instead of just having x by itself, where then it would intercept 0 at pi. The last thing that needs to be analyzed in graphing this sine function is the function of this -3 here. Now, the negative sign in front of the sine indicates that the sine function will start by decreasing, because the negative causes it to decrease and then increase, as well as the 3 in front of the sine shows just how much the function will decrease and increase. So from 0, this only decreases to -2, so by 3 points, and then increases all the way up to 4, which is by 6 points, each 3 points away from the 0. So this is what the graph looks like with the cosecant function graphed. These pink lines right here are the cosecant graph, and as we can see, just by analyzing these lines, they meet the point of the sine function, and they stay within these periods. The reason that they stay within these periods is because they can never reach 0, because because the cosecant function can never be less than 0, because it can never be less than the absolute value of the sine function. So it's never going to be able to reach that 0 just because of its fraction. There's always going to be a 1 absolute value, 1 over sine there. So as we can see, up here we have at each opposite end there is the cosecant graph, which is the reciprocal, the exact opposite of the sine graph. And that is my explanation for graphing this function. Thank you so much for your time.